All right, people, here we go. Review for the semester one final for principles pre-calc. We got this. We're going to divide it into two things, basics in chapter one today, or in this video, and then another video have chapter two and chapter three. Boom, there we go. So we're going to start off, we're going pretty basic. This is way back at the beginning, graphing and finding linear equations. So we're going to graph here, we're going to find here, and we're off to the races. This one is in slope intercept form, the most standard form. So we're going to go up to 6. 6 is right there. And then our slope is either -2/3 or 2 over -3. We could go either one. I like the -2/3 because that's going to go down 2 and over 3. Whereas the other one was up 2, right, and back 3. Again, it's on the same line, but it's a little easier to see this one. Boom, boom, there we go. Probably be a good idea to put a couple numbers in here, right? 1, 2, or something like that. All right, 2x minus 3y equals 9. When it's in this form, this is standard form. I like to find the x-intercept, and I like to find the y-intercept. To find the x-intercept, that means to find the x-int equals, we make y equals 0. So if I make y equals 0, minus 3 times 0 is just 0. So we really just have 2x equals 9, right? So if y is 0, 2x equals 9, x is equal to 4.5. So I'm going to go over here. My x-intercept is at 4.5, 3, 4, 4.5, right there. All right, let's find my y-intercept equals bloop. That happens when x equals 0. So when x is 0, 2 times 0 is 0. So I cover that up. And I get -3y equals 9. So I'll write that down. -3y equals 9. So y is equal to -3. I don't even do all this, right? I just go, boom, x, 4.5. Boom, y, -3, right? So -1, -2, -3, and voila. Good, good. Again, probably a good idea to put some numbers in here. This is 2, this is 2, just so we have a scale since it's not already on there. All right, this is in point slope form. Okay, the point is going to be whatever makes this equal to 0 is my x. Whatever makes this equal to 0 is my y. Okay, so -3, 1 is the point. My slope is -2. So point slope form. Um, you usually don't graph from this form. What you might usually do, what might be easier is to distribute through here, -2x minus 6, and then add 1 to both sides, right? And to turn it into this form, you can totally do that. It's totally fine. But you should also be able to look at it and go, okay, this has got to be the point. This has got to be the slope. All right, so -3, 1, 2, 3, +1, so we're there. Slope is -2, so that means rise -2, run 1. So there we go. Done. All right. Find the equation in the following scenarios. This one gets kind of nasty, but we'll do it. All right. It's okay if numbers get a little funky. We're going to get some fractions in this one. These will be a little nicer. Find the equation of the line that goes through this. So I need to find the slope first. So y minus the other y. So 3 minus -5. I make it ugly like that, right? I'm going to fix that later. And I have to go the same direction. 3 minus -5, -2 minus 4. All right, so on the bottom we get -6. On the top we get 3 plus 5, which is 8. So we have -4/3 is my slope. Cool. Now all I'm going to do, I'm going to rewrite it. Y equals -4/3 x plus b. I need to find b. So I can plug in either of these two numbers, x, y, into the xy here. So I'm going to use this number. I could use this or this ordered pair rather than this one. Doesn't matter which one you use. These numbers seem smaller though. So x is -2. So instead of x, I'm going to write -2. And I'm going to put that over 1 just to make the fraction easier. And then my y value is +3. And let's go. 3 equals +8/3. Negative times a negative is positive. 3 times 1 is 3. Plus b. I'm going to change this because I know I'm going to have to subtract 8/3 from both sides. I'm going to cut this in thirds, so that's 9/3. Then I'm going to subtract 8/3 from both sides. And that'll equal b. So b is equal to 1/3. So now I'm going to rewrite it. I'll rewrite it down here. Y equals -4/3 x. We had that before. I just needed to add in the b. So it's going to be plus 1/3. Cool. There we go. That's a 3, people. All right. Here we go. Got a little ugly, right? It's okay. Here we go. Goes through 2, -5, and is parallel. Parallel means I'm going to steal the slope. So I know the new line has slope equaling to 3, and it goes through the point to -5. So I'm going to use that knowledge, plug it all into y equals mx plus b. So y equals mx plus b. Now I'm going to be able to find the b. -5 equals 6 plus b. Subtract 6 from both sides. So we get b is equal to -11. I got the slope. I got the b. So now let's write it in. Y equals 3x minus 11. Nice. All right, here we go. Equation goes through 0, 3 and is perpendicular to this. So perpendicular, my new line is going to be perpendicular to this old line. So the slope is going to be, do you remember what to do? 2 things, flip it and make it the opposite sign. It's positive, now it's negative, right? And then my point, and this is a special point. Can you figure out why that's special? 0, 3, graph 0, 3. 0, 3. What is that? That's the y-intercept. We can cheat here. We don't have to do all that work. We got the slope and the intercept. We're done. Y equals -2/3 x plus 3. Done. Now you could have plugged the 3 in here, I'm sorry, the 0 in here and the 3 in here and solve for b, but b was going to be 3 no matter what you did. All right, good stuff. All right, solving some equations here. All right, so for linear, we want to make both sides as nice as possible. So I'm going to distribute first. 2x minus 4 plus 3 equals -3x plus 2. I've got some more work to do on this side. -4 and plus 3 are like terms. So 2x minus 1 equals -3x plus 2. Now I need to get all the x's on one side. So let's add 3x to both sides. 5x minus 1 equals 2. We're going to add 1 to both sides. So 5x equals 3. Divide both sides by 5, x equals 3/5. And if you have time, put it back in and see if it works. All right, radical, we want to, step number 1, isolate the radical. We want to isolate this all by itself on one side, no matter if this is a cube root or a fifth root or anything else, or if there's more stuff inside, we just need to get the square root by itself on one side first. So we'll subtract 5 from both sides, subtract 5. So I get root 25x equals 10. And the next step is to, how do we undo a square root? We square. So 25x equals 100. Divide both sides by 25, and x equals 4. We need to check to make sure it works. Anytime you square both sides, we can introduce things that do not work. So let's go. 5 plus root 25 times 4, does that equal 15? 5 plus root 100 equals 15. That's going to be 10 plus 5. Yep, we're good. I don't need to go any further. Once I know it works and see it works, I'm good. All right, quadratic. We need to get everything on one side, right? And we need it to equal 0. We need blob equals 0 to solve a quadratic, right? Unless you're completing the square. And people who do that, they're wild, wild people. So I'm going to add an a to both sides. This side doesn't have an a term, so I'm just going to kind of put it in between. I'm going to subtract 3a squared from both sides, so I'll put that underneath there. So 4a squared minus 3a squared is a squared. There's just a rando plus a, and a rando minus 30 equals 0. All right, now I need to factor, right? So what times what is -30 and adds up to 1? We know this has to be, to do that, we have to have a plus and a minus. So a positive and a negative that multiply to 30 but add up to 1. Options are 30 and 1, 15 and 2, 10 and 3, 6 and 5. Any of those look good? Yeah, 6 and 5, right? So 6 and 5 were the ones that work. So this is a plus 6, a minus 5, and that equals 0. You could FOIL it out and make sure it works. Always a good idea. Quick check, right? A squared minus 5a plus 6a. That's a. Minus 6 times, sorry, positive 6 times -5 is -30. So a is equal to negative 6 or positive 5. What makes this 0? What makes this 0? Those are my two answers. Cool, cool. All right, here we go. Solve by graphic. Y equals 2x minus 1. So I go to negative 1. It's right there. Slope is 2. Rise 2, run 1. Rise 2, run 1. Rise 2, run 1. I like to get a few of those going in a row. Answer is probably going to be on one of those points unless I mess up and make it not on a point. I would never do that. All right, so this is in standard form. So we're going to find, let's go the x-intercept first. So cover up the y. 3x equals 12. X equals what? X-intercept is 4. 1, 2, 3, 4. All right, standard form. I'm going to find the y-intercept. 2y equals 12. 6. I think that's right there. Let's go ahead and graph this. Oh, nice. It worked perfectly. All right, so we need to say the solution is 2 comma, I believe it's 3. 1, 2, 3. 2 comma 3. There it is. So this is going to be the same answer for all these. Okay, we're just doing it different way. So solve using substitution. Y equals this. We need to have either x equals something or y equals something to use substitution. So now in place of y here, I'm going to substitute this in for it. So 3x plus 2 times this y, 2x minus 1, equals 12. I'm going to distribute 3x plus 4x minus 2 equals 12. We're going to add 2, 3x plus 4x is 7x. Ooh, that's ugly. I hope this works. 14. So x equals 2. We are good. All right, y equals 2 times x minus 1. So 4 minus 1. So y has to be, looks like 3, which makes sense. 2 comma 3. And you could leave the answer like that is fine. X equals 2, y equals 3. Or you could write it as 2 comma 3 because it is a point, right? Okie dokes, artichokes. Here we go. Solve using elimination. Elimination means I'm adding down. But when I do that, something has to go away. And if I add down now, I get 1x and I get 3y. I didn't eliminate anything. So I need to change one of these two so that we do eliminate. So I either need a negative 3 out front here, which I could do by multiplying by 1.5, or I need a negative 2 here so that negative 2y cancels out positive 2y. I think that's the easier way to go. Okay, so I'm going to multiply both sides by negative 2. And I'm just going to rewrite it right below this. So negative 2 times negative 2x is positive 4x. Negative 2 times positive y is minus 2y. Negative 2 times 1, negative 1 is positive 2. And now I add them together. 7x equals 14. Does that look familiar? It does look familiar. Oh my gosh. So x equals 2, and we'll soon find out that y equals 3, 2 comma 3. We do it the same way we did here. Plug it into either equation. Cool, cool. All right, good work. All right. Simplifying radicals. All right, all right. So negative on the outside, that means something. This one has a negative on the inside. So this means the opposite of 2x squared, right? We're going to do this first. Okay, so negative 2x times 2x is 4x squared. Over here, it's negative 3x times negative 3x, right? You could always pull it out and think about what that means. Negative times negative, positive. 3 times 3, 9. X times x, x squared. There we go. So we got negative 4x squared. I could just write it like that. Times 9x squared. It's going to be negative 36. X squared times x squared, x to the 4th. Beautiful. That looks great. Nice job. All right, here. I'm going to square this. So this means 2xy times 2xy. That's going to be 4x squared y squared. 2 times 2, x times x, y times y, right? You could also think of this 2 as kind of like distributing to all of those. It's not really distributive property, but it kind of feels the same. All right, here we've got 4x squared and y to the negative second power. All right. So a lot of students like to do this once they've gotten here. Oh, that's -2, right? They like to divide this out. So 4 over 4 times x squared over x squared times y squared over y to the negative second power. This is a giant one. This is a giant one. Anything divided by itself is just 1. So all we have left is this, y squared over y to the -2. I like to think about my little brother or me or my little brother, right? The upstairs bunk and the bottom bunk, right? And this time, the person on the bottom bunk is the unhappy one, right? They want to go to the top. There's already 2 up there. If these 2 go up to the top, how many do we have there? Yeah, we got y to the 4th now, right? The other way to do it is to go, anytime we divide, we keep the base, and we take the top exponent minus the bottom exponent. So 2 minus -2. 2 minus -2 is really 2 plus 2, which is 4th power. All right, simplifying these, we're going to do the good stuff and the bad stuff. Okay, it's a good idea to go back and look at your perfect squares, right? 2 squared, 3 squared, 4 squared, 5 squared, and ask yourself, any of these times something equal 24? Yeah, and if you said 4 times 6, you are right. So 4 times 6. Square root of 4 is 2. So this is 2 root 6. Once you use the square root, it goes away, right? Square root of 4, a lot of people have been writing square root of 2. No, once you use it, you square root 4, it is 2, right? All right, over here, same idea. We're going to put the good stuff first. We're going to put the not so good stuff here. So for 18, any of these look familiar? Anything times something, one of these equal 18? If you said 9 times 2, you are correct. So I'm going to do a 9 here and a 2 here. 9 times 2 is 18. We could put a multiplier in here if we want. All right, x squared. Is that a perfect square? Yeah, that's x times x. So that goes here. And then y to the 7th, the most y's I can get out is y to the 6th. So that's going to go there. So we have 1 y left over. All right, square root of 9 is 3. Square root of x squared is just x. Square root of y to the 6th is y to the 3rd. And then we're left with a 2y at the end. Beautiful? Definitely beautiful. Just absolutely gorgeous. All right, we're halfway through this. That's good. Here we go. Functions, parents, and transformations. So parent function, I want you to identify that. The parent function for this one, get rid of the plus, the -1, and the -2. We are left with just y equals x squared, right? I encourage you to graph that parent function. You could use a different color, something like that. That's kind of nice. And then identify what we're doing. -1 inside next to the x means we're actually going to the right by 1. This on the outside means we're going down 2. So I'm going to take the most important point, which is a vertex, and go right 1 and down 2. That's my new vertex. And now I'm just going to copy and paste this, but it's down here. Cool. Cool. There we go. There's a new function. All right. Again, so find the parent function, y equals square root of x, right? Square root of x starts at the origin, goes through 1, 1, and then goes something like that. So that's the parent function right there. And what are we going to do with it? This is going to flip it up and down. Okay. This 2 here is going to stretch it by 2. Okay, so it's going to be, imagine stretching it this way, doubling its height going up, right? So instead of going through, if it goes through 0, 0, instead of going through 1, 1, it's going to go through 1, comma 2, right? So it's going to be going up faster, right? Way to think of it. And then this +2 on the inside means it's actually moving left by 2. All right, so maybe I kind of look at what the stretch is going to do first, and then I think about what the flip is going to do to it, right? And then everything's moving left by 2, so I'm going to move it over 1, 2. So it should look something like that. Cool? Cool. All right, last one. Ooh, parent functions y equals x cubed. Okay, so graphing the y equals x cubed, it looks like a parabola this way. It looks like a turn down parabola going this way. So there's y equals x cubed. And what are we doing to it? Amplitude, or sorry, kind of amplitude, same idea, but it's going to be a stretch by factor of 3. This means it's moving left 1. This means it's moving up 2. All right, the most important point is this one that goes through here, and we're moving left 1 and up 2, and it's going to go up faster than before. So it's going to look something like that. Close enough. That's all we're after. Close enough. All right, piecewise functions. Piecewise functions. So one way to do this that I've shown before is to graph each of these individually. Okay, so this means y equals 2. So let's graph y equals 2. The middle one is y equals x squared plus 1. So we're going to graph y equals x squared plus 1. The last one is y equals 2x minus 3. So we're going to graph y equals 2x minus 3. So let's just graph all three of those first. Okay, y equals 2. Looks like this. I go up to 2, and it goes across like that. Y equals x squared plus 1 is just a parabola that goes through 1 comma 0. All right, so it looks like that. Cool. Y equals 2x minus 3 is we go through -1, -2, -3, and we have a slope of up 2 over 1. So it's a line that does that. Cool. So I have those three things, right? So I graph those three, and then I figure out where they work. This one, the first one, only works with x values less than or equal to -1. So at -1, I'm going to make a cut, and it includes that. So I'm going to do a solid line, and I'm going to take this and put this over here. So at -1, I got a solid, and it's going over, and it's where y equals 2. So -1 here, go up to 2, solid line going over. So I've copy and pasted this part because that's the only part I want to take. Cool. All right, this one here, I'm going to take from between -1. So I'm going to start here, and I'm going to go until we get to +2. So 1, 2. Okay, so I'm going to take that and copy and paste. All right, so I know it goes through here. Okay, I know how parabolas work, over 1, up 1 if there's nothing else going on. So this on this side is going to go right to that point. Oh, that's great. This one's going to go through that point, and then I know it's over 1, up 1. I know it's over 2, up 4. 1, 2, 3, 4. But this point here is not inclusive, so I'm going to leave it open for now. Okay, so there we go. That's what I've got from the middle one. So I've copied basically and pasted that over here. This one is trickier because it's going over to 2. So it's like somewhere up here, I'm going to cut it off, and I'm going to take this part. Anything that is greater than or equal to 2 on this line, I'm going to take. So here's what I do. I go y equals 2x minus 3. So I go to -3. I'm going to go from here up 2 over 1, up 2 over 1, and this is where this one's going to start, right? And it's inclusive. So I'm going to go dot and up 2 over 1, and there we go. Good, good. Now, is this continuous? No, it goes up to here, and then suddenly it drops down to here, and then goes forever. Okay, but it is a function. It's just a funky function. Cool, cool, cool. All right, to find the inverse, step number 1, make your f of x equal y. Copy everything else down. Then you switch your x and y. X equals 2y squared minus 3. And now we want to get the y by itself. So that means I got to get rid of that 2. I got to get rid of that -3. I got to get rid of that 2, the exponent 2. So what's the easiest one to get rid of? Is the -3. So let's add 3 to both sides. So I get x plus 3 equals 2y squared. What's the next easiest thing to take care of? Yeah, the times 2, right? So let's divide everything by 2. So x plus 3 over 2 equals y squared. I'm getting close. How do I undo y squared? I square root, right? So y equals, I'm going to flip these sides. I'm going to square root both sides. Add plus minus. So plus or minus square root of x plus 3 over 2. And I've solved for y. Now, the fancy thing to do is this was f of x. So I'm going to write the inverse as F inverse of X equals plus or minus X plus 3 over 2. Now, technically, this is not not a function anymore, right? It's going to be basically a sideways parabola, so it's lost its functionness. I could graph two different parts, the positive part of this and then the negative part of this, and that would be functiony. But we'll just go with it. We'll go with it. It's more the process. Trust the process, y'all. Trust the process. All right, here we go. Operations and composition. So I've got three machines here, the F machine, the G machine, and the H machine. They all do different things. This takes an input, adds 3. This takes an input and squares it. This takes the input, adds 1, and then square roots, whatever you get. Okay? Down here, it's going to tell us what to use and how to use it. Okay, so this one says use the F machine and plug in 3. So F machine, plug in 3, so that's going to be 3 plus 3. And then I'm going to add it to the H of 24. So I go to the H machine and I put in 24. So plus root 24 plus 1. 3 plus 3 is 6, plus square root of 25 is 5, so that's going to be 11. Not bad, right? Not bad. All right, F plus G of 2 is the same thing as F of 2 plus G of 2. So this means just take your F machine and plug in 2. 2 plus 3, that's going to be 5. This says take your G machine and plug in 2. Plug in 2, that's going to be 4. So that's going to be 9. Easy peasy, right? F over G of 8 just means F of 8 divided by G of 8. Okay, so I'm going to take the F machine and plug in 8. That's 8 plus 3, which is 11. I'm going to take my G machine and plug in 8. Oh my gosh, that's a lot. 8 squared is 64. That's all I can do there. Cool, cool. All right, next one. This says f of x equals 8. Now, it doesn't say f of 8 equals something, right? So we're not plugging 8 into the f machine. But what I can do is a little substitution, right? F of x equals 8. I know what f of x is. F of x equals this. So I'm just going to replace it. Instead of f of x, I'm going to write x plus 3 because they're equal. They're the same thing. So I could write either one I want. X plus 3 equals 8, and x would have to be 5. Basically, this is saying, what do I need to plug into the F machine to have it spit out 8, right? If I plug 5 into the F machine, it's going to spit out 8. Make sense? All right, G plus F of x means G of x plus F of x, right? Notice there's no numbers in here, so I'm just going to write what the formulas are. G of x is x squared. F of x is x plus 3, and that's all I can do. So what I'm doing is I'm generating a new equation or new function that is the combination of two other functions. Cool. All right. G of f of x means I'm plugging, I wish I had one more of these problems. I'll probably add one for you here. This means I'm plugging f, and in fact, let's skip this one for a second. Let's do G of f of 2. Okay, so let's do this problem first. All right, so add this. So I'm going to work from the inside out. So I'm going to go f of 2. So I'm going to plug 2 into my f machine. Okay, so f of 2 is equal to 2 plus 3, which is 5. So if f of 2 equals 5, I can just write 5 instead of f of 2, right? They are equal. F of 2 equals 5. So it equals 5. So now I'm going to plug that output, which was 5, into the G machine. G of 5. So you go up here. G machine means we square root whatever it is, and that equals 25. So we're working from the inside out on this one. So start on the inside, figure out what that is, plug that into the other one. There we go. This one, I have to plug the equation in. So f of x equals x plus 3. We're just going to plug that in. So g of x plus 3 equals. So this means I'm going to plug x plus 3 into the G machine. Okay, so my input is x plus 3. What do I do to the input? I square it. You could leave it like this if you want, Or you could FOIL that out and make it x squared plus 6x plus 9. Your call. I'm okay with either one. Factored is nice. And people, that is it for chapters, the basic chapter that we did and chapter 1. Next up will be this in just a moment. Peace out. Ooh, did I stop it? I don't know. Let's try again.